Hi everyone, welcome back to the Comptia Network Plus course. Mitigation. But you're not helpless. One way to keep rogue APs out of the wireless network is to employ a wireless LAN controller, WLC, to manage your access points. This is a nice mitigation technique because APs and controllers communicate using lightweight access point protocol, LWAPP or newer CAPWAP, and it just so happens that one of the message types they share is called radio resource management. Basically your access point, your AP monitors all channels by momentarily switching from their configured channel and by collecting packets to check for rogue activity. If an AP is detected, this isn't usually managed by the controller. It's classified as a rogue, and if a wireless control system is in use, the rogue can be plotted on a floor pan and located. Another great benefit to this mitigation approach is that it enables your APs to also prevent workstations from associating with newly exposed rogue. Ad hoc networks. As you already know, ad hoc networks are created peer-to-peer or directly between stations and not through an AP. This can be a dangerous configuration because there's no corporate security in place, and since these networks are often created by unsophisticated users, you end up with a scenario I just described that's primed for and wide open to peer-to-peer attack. Even uglier, if the laptop happens to connect to the corporate LAN through an Ethernet connection at the same time the ad hoc network is created. The two connections could be bridged by a hacker to gain them access straight up into the wired LAN itself. Mitigation. When you've got a Cisco Unified Wireless Network CUWN in operation, ad hoc networks can be identified over the air by the kind of frames they send, which are different from those belonging to an infrastructure network. When these frames are identified, the CUWN can prevent harmful intrusions by sending out information known as de-authentication frames to keep your stations from associating via ad hoc mode. Denial of service. Not all attacks are aimed at the goal of stealing information. Sometimes a hacker just wants to cause some major network grief, like jamming the frequency where your wireless LAN lives, to cause a complete interruption of service until you manage to ferret out the jamming signal and disable it. This type of assault is known as a denial of service attack. Mitigation. And this is how we deal with them. First, if someone is jamming the frequency, there isn't much, if anything, you could do. However, many denial of service, man in the middle and penetration attacks operate by de-authentication or disassociation stations from the network. Some DOS attacks take the form of simply flooding the wireless network with probe requests or association frames, which effectively makes the overwhelmed network unavailable for non-formal transmissions. These type of management frames are sent unauthenticated and unencrypted. Since de-authentication and disassociation frames are classified as management frames, the management frame protection MAP mechanism can be used to prevent the deluge. There are two types of MFP you can use, referred to as infrastructure and client. Let's take a look at each of them now. Infrastructure mode. This suite strangely doesn't require configuration on the station, only the AP. Controllers generate a specific signal for each wireless LAN which is added to each management frame it sends, and any attempt to alter this is deleted by the message integrity check MIC in the frame. Therefore, when an AP receives a management frame from an unknown SSID, it reports the event to the controller and an alarm is generated. When an AP receives an MFP protected frame from an unknown SSID, it queries the controller for the key. If the BSSID isn't recognized by the controller, it will return an unknown BSSID message, which causes the AP to drop the frame. Client mode. Often rogue APs attempt to impersonate the company AP with the client MFP. All management frames between the AP and the station are protected because clients can detect and drop spoofed or invalid management frames. Passive attacks. So far, the attacks I've talked about are in the category referred to as active attacks because in deploying them, the hacker is interacting with stations, the AP and the network in real time, but be aware there are other ways into the fort. Passive attacks are the most often used to gather information to be used in an active attack a hacker is planning to execute later, and they usually involve wireless sniffing. During a passive attack, the hacker captures large amount of raw frames to analyze online with sniffing software used to discover a key and decrypt it on the fly, or the data will be analyzed offline, which simply means the bad guy will take the data away and analyze it later. Mitigation. In addition to the tools already deployed, you can use an intrusion detection system IDS or an intrusion protection system IPS to guard against passive attacks. IDS, an intrusion detection system, is used to detect several types of malicious behaviors that can compromise the security and the trust of your system. These malicious behaviors include network attacks against vulnerable services, data-driven attacks on applications, host-based attacks like privilege escalation, unauthorized logins, access to sensitive files, and malware like viruses, Trojan horses, and worms. An IPS, an intrusion prevention system, is a computer security device that monitors network and or system activities for malicious or unwanted behavior and can react in real time to block or prevent those activities. For example, a network-based IPS will operate in line to monitor all network traffic for malicious code or attacks. When either is detected, it can drop the offending packets while still allowing all other traffic to pass. Which approach you will opt to go with depends on the size of your wireless network and how tight your security needs to be. The goal of a security mechanism is to provide three features: confidentiality of the data integrity, an ensured identification process, and when faced with decisions about security, you need to consider these three things: the safety of the authentication process, the strength of the encryption mechanism, its ability to protect the integrity of the data. Open access. All Wi-Fi certified small office, home office, wireless LAN products are shipped in open access mode with their security features turned off. Although open access or no security may be appropriate and acceptable for public hotspots such as coffee shops, college campuses, and maybe airports, it's definitely not an option for an enterprise organization, and it's probably not even adequate for your private home network. With that, what I've told you so far, I'm sure you agree that security needs to be enabled on wireless devices during their installation in enterprise environments, yet surprisingly many companies don't enable any of them. wireless LAN security features. Obviously the companies that don't enable security features are exposing the networks to tremendous risk. The reason that the products are shipped with open access is so that any person who knows absolutely nothing about computers can just buy an access point, plug it into their cable or DSL modem, and they're up and running. It's a marketing, plain and simple, and simplicity sells. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.